1, edit. Now there's information in the table, so you have to go back to stat again and we have to clear the list, which is number 4. Clear list 1, second list 1, comma, second list 2, enter. Then we have to go back to stat, edit. We then have to put in data here. Let's say I wanted to find out the relationship between the following bits of data. I'd put in some numbers here. This is going to be your BPM. And then in list 2, you're going to put in your song length in seconds. Then what you need to do is you need to calculate things to do with this. So you're going to go back to the stat menu, you're going to press calc. On calc, we're going to go on to Lin regression, AX plus B, which is number 4. And we press calculate. Y, A, B, R squared and R. Do you know what this means? So if this was your result, your equation of your straight line would be Y equals, A is 89, 89x plus B, which is 17. So when you look at the graph, you can't see the graph. So the way to see it on the calculator, you'd press second stat plot. Number 1, stat plot on. Enter the information, graph. You can see it, but the window's not big enough. So we need to make sure we can see more of the window. We've changed the numbers. Press graph, and then you can see more of the points. This is a bit of a rubbish graph. So that is Pearson. And Pearson, this is the equation of a straight line. And the R is the Pearson. You remember what Pearson tells us? It's got a strong association if it's between 0.5 and 1, and negative it's negative 0.5 and 1. So what I mean by that is we have positive gradient. If it's completely positive, it will be 1. No correlation, where the points are all over the place, but Pearson will be 0. Negative correlation, it will be negative 1. So basically, if it's somewhere between these numbers, which it will be, it will tell you how strong the correlation is. So that tells you how strongly linked the variables are. So if it's close to 1, the variables are going to be very close together, which means there is a link between song length and BPM. If it's really close to -1, there is a link. So we're going to say that as the song gets longer, the BPM gets smaller if it's -1. Whereas if it's +1, as the song gets longer, the BPM gets faster.
Okay.
Does that make sense?
I think so.
I'm going to record this so then you can put that in writing. So you're going to talk about the relationship between the song length and the BPM. You need to describe the line of best fit. You can do it on Excel as well. So this is the way it works. You get your equation of your line, and your equation of your line, you can either use spreadsheets or you can use what we did here. We've got the 89 as the A, the 17 as the C, and you just substitute X for whatever BPM you want. If you substitute in the correct BPM, that will then give you the song length. You're going to use a BPM or a length which you haven't got list to say that I want to analyse one of my favourite songs, but I haven't got it on this list. The BPM is a bit of an anomaly, so I'm going to substitute in the BPM for X. So like you said, you could substitute in the 79. You do 89 times 79 plus 17, and then that would generate the song length. That's obviously not going to work because this equation's wrong, but with the correct equation it'll work. And also, if you do it for this song, this number's not going to exactly come out. And the reason why is because you're going to have a straight line. You're going to have coordinates like this, but they won't necessarily be on the straight line. So what it will do is it will generate what it expects it to be. And then you could maybe compare it to the actual result. You could say, well, the actual result is much higher, and this could be because of this.
Okay.
So that's the first sort of main bit of maths you could do.